In this video, we're going to go through Kentik's new Cloud Latency Map, a free public tool that allows users to explore latencies measured between over 100 cloud regions around the world. This tool has two main sections, the Latency Changes section and the Latency Comparison section. Let's start with the Latency Changes. So there are three sub areas here that we can specify cities that we wish to explore latency changes. So let's try one. Here we're in latency changes by city and specify a particular city that I happen to know is experiencing a latency change. So there, we'll get rid of this Ashburn event, but otherwise we can see that these latencies all experience a jump about the same time. There was a connectivity issue in the continent of Africa on just a few days ago, causing these latencies to jump. And we see this exhibited by AWS measurements from AWS's region in Cape Town going to the Middle East and Asia. We can see that affected both their measurements between, their connectivity between AWS and other AWS regions, as well as other clouds. We can see some of these other options that are down here as we scroll through this list. Yeah, and so we can isolate this to occur around, somewhere around this time here, right below the graph. It pops up when you click into the graph. So it's around 0700 UTC on October 25th that all these latencies jumped up. And that is a demonstration of this capability. So we can also change the Cape Town to be the destination, and we'll see roughly a similar thing. Sometimes there's some subtle differences in how traffic gets egressed or ingressed at the cloud regions. So sometimes there is some difference. But again, we're seeing this particular feature show up on this one time around 0700 on October 25th. So that's the city level, which is quite powerful. We have quite a lot of cities located included in this tool. We also specified by geo, and so in this case, we can look at set the source agent to be somewhere in the Americas, Asia, or EMEA. Same thing for the destination. In this case, I happen to have already pulled up this Asia to Asia query, and we can see that there was a change here around on October 22nd. We noticed that the connectivity in and out of AWS's cloud region in Beijing, China had changed. A lot of the latencies within the region to that cloud region got better, as well as maybe got a little higher from Europe. That may have been an intentional design change, but nonetheless, it got captured in the cloud latency map. And lastly, we can kind of dig into, if we want to just say, okay, all of the measurements between one cloud and all clouds, or one cloud and another, or stay within a cloud. Here in this case of this AWS, the biggest changes we're seeing are, we're seeing a couple that were affected by the event in Africa. We can see the green line is measurements going into Beijing, China, where it looks like during weekdays, it got quiet over the weekend. Today is a Monday. And then that, again, today is a Monday where the latencies are spiking up. And yeah, so we can see these changes. Those are the top 5 changes that we saw in the past 7 days from our agents embedded somewhere in AWS to somewhere else in AWS. So that's the latency changes section. And so if we skip over to the latency comparisons, whereas the previous section was trying to find and identify changes among about 10,000 plus data series, in this case, this is a smaller task here. We're trying to look at latencies between two cities and how the same clouds connect across those common routes, same source and destination. We're trying to create a apples to apples comparison. And then because a lot of these links are very, very stable, we don't see a lot of changes, a lot of the latencies are very tight, they're very optimized, that we highlight what are the biggest changes between the best and lowest, highest and lowest latencies. And here's an example of that. So we can either go intra-cloud and stay within one cloud, and those are typically lower latency differences. In this case, today, they're actually on par, but in general, these are usually about the same. Or intra-cloud latencies the differences are much lower. If we look at this case, we're looking at the latencies we see GCP being the slightly higher, about 30 milliseconds higher than the other two examples, about 38 milliseconds from the medians of these measurements. And we can switch over to Intra-Cloud and look at if we were going strictly from one cloud to another between Mumbai and Sao Paulo, what would be the latencies we would see there? And we can we've got this color coded by the 6 different options. These are all the permutations of starting in one cloud and having to land in another one when we're just looking at AWS, Azure, and GCP. And then you can self-guide around and look at set locations and source and destinations. And we got a big spike here going between particular cities. So that's the latency comparison section. We've got a little FAQ, but otherwise it's latency changes, latency comparisons. Take it, try it out, see if you can find something interesting or confirm some sort of connectivity you may be experiencing. Let us know what you think.